Factoring trinomials using the rainbow method, example 5, finding prime polynomials. For example, the first one will be 6x squared plus 10x plus 3. So first we write the expression in standard form, ax squared plus bx plus c, and it is. Now we need to find a, b, and c. A is equal to 6, b is equal to 10, and c is equal to 3. We'll multiply a and c together. So a times c is equal to 6 times 3 is equal to 18. Now we need to find all the factor pairs for 18, starting with 1 times 18. As we increase, we have 2 times 9, and then 3 times 6. And we found all the factor pairs. Now we need to link our factor pairs together. So 3 and 6 is linked together. 2 and 9 are linked together. And 1 and 18. Let's find the sum and difference for each factor pair. On the upper corners, we'll have the sum, and on the lower corners, the difference. For 1 and 18, the sum is 19, and the difference is 17. For 2 and 9, the sum is 11, and the difference is 7. For 3 and 6, the sum is 9, and the difference is 3. Now we'll locate b and mark the pair it's used. b is equal to 10. As we look along our corners, we notice there's no 10 on any of the corners there from any of the factor pairs. So we're unable to form the 10 with our factor pairs either by adding or finding the difference of them, and we're unable to continue with the factoring. And that indicates we have a prime polynomial. For our second example, let's look at 2x squared plus 7x minus 3. Again, we write the expression in standard form, ax squared plus bx plus c. We need to find the a, the b, and the c. A is equal to 2, b is equal to 7, and c is equal to 3. Multiplying the a and the c together, we have 2 times 3 is equal to 6. We need to find all our factor pairs for 6, starting with 1 times 6. Increasing it, we have 2 times 3. And we found the pairs. So let's link our factor pairs together. The 2 and the 3 are linked together, and the 1 and the 6. So we need to find the sum and the difference for each factor pair. We'll put the sums on the upper corners and the difference on the lower corners. 1 and 6, we could form a 7, and the difference is a 5. For 2 and 3, the sum is a 5, and the difference is 1. Now we're trying to locate b and mark the pairs used. So b is equal to 7. And we see we have a 7 on this upper corner, and we used 1 and 6 to form it. So now we'll rewrite the expression with this pair. So we'll write the first term and the last term with some space in between. We're trying to form a positive 7x using the 1 and the 6. So we have a plus 1x plus 6x, and combined together they form a 7x. Now we'll factor by grouping. We have our first group and our second group. From the first group, we can factor out an x, leaving 2x plus 1. From the second group, we can factor a 3, leaving us 2x minus 1. But checking inside the parentheses, these expressions are not identical factors, and we're unable to continue. Let's try to factor something different then. So from the first group, we'll factor a 2x plus 1. But for the second group, let's factor a negative 3. And that'll leave a negative 2x plus 1. But again, checking our expressions inside the parentheses, these are not identical factors. Hence, we have a prime polynomial, as we're unable to continue with the factoring. These are the two ways you can identify a prime polynomial with the rainbow method.